So for section 4, we're going to look at a more complicated problem. That's sunspot data. You may remember from science class that sunspots are spots in the sun, and we can look at them. They vary, and so if we look at them every, average every month, they tend to increase over the years and then decrease. They tend to follow an 11-year cycle, so they'll increase for 11 years and then decrease 11 years. And we're pulling this from this Sunspot data, which is a well-known time series example. What's nice about it is it increases and decreases somewhat regularly. So we're going to look at this network here and set things up. And then you're going to come back here. We're just going to run through this code like I'm going to do now. And then you're going to answer these two questions. How well does the sunspot data predict the next 1 month ahead? And how well does it generate a prediction 30 years ahead? So again, we just read in the sunspot data here. I've taken it from this website and put it on GitHub, and so it's a little easier for us to access directly. We then do a number of things. We have data from the 1700s. Here you can see the first data from 1749, and initially there's a number of not a number, some bad values here. So we're just going to skip over the first data and just go with the last 200 years, or the most recent 2,400 readings there. And we're going to plot that data. And again, so this is every month. It goes up, every dot, every number is a month here. So this doesn't correspond to years. This is from the starting point onward month-wise. And so every about 11 years, we see a growth and then a decline and another growth and another decline in this sunspot data. How much it grows and declines varies a little bit, but again, we see this pretty typically. Okay, so and notice that most of the peaks are, around 250. So again, those are some big numbers. So we're going to prep the data for our database. We could run a min-max scaler, but again, this is just a single variable and it maxes out around 250. So I'm just going to divide all the data by 250. It's okay if some of the numbers are slightly above 1. That's okay. And then we're going to break the data into some training and test data sets. Originally, I was dividing it by the year 2000 and then after 2000, but I just decided for some purposes, we'll just do the first 2,000 readings. And then so we have 2,000 readings for training and 400 readings for testing here that we're going to work with. Then we're going to break this data into sequences. What we want is, what we want to do is train the data on 48 months. So it'll be 48 months of readings, and then have it predict the next month, and then we'll look at 48 months. So we'll segment all these data into 48-month segments, where it then predicts the next month. Here, and you can actually you can use different things, but for now we're using 48 months. It's about 4 years worth of data and then predicting one. The longer the sequence, the longer training will take here. So what we end up with is we started off with 2,000 observations, but now we're going to break it into sequences that are 48 months long here. And then we get 100 and 1900. We lose a couple because we need these sequences for data. So we have almost 2,000 sequences here, and same with our testing data similarly. And again, so we'll have each sequence will be 48 months long, and then we get a single prediction. The output will be the next month's data. Here. So this routine is used in a lot of these. It's a standard routine just to break the data up into sequences like this. I'm not going to go over that routine, but that's what it does. Okay, now something that we'll get into more is training the network. So again, we're building a sequential network here. Right now we're just using a long short-term memory layer with 32 nodes in it. And then we're feeding it to a dense layer with 16, and then the output is 1. Again, we're just predicting 1 the next month's data from that. And the information will be fed into this one at a time. So our input shape here, this none means that we can vary the sequence length. So you can actually, if you want, you can change this, this sequence length. Right now we're going to feed in a sequence of 48 months. So it'll see each month's data one at a time, slowly, and then eventually be trained to predict the next month here. That's what this one output is. But so you can change this, the dense layer here. You could change the size of this. You could actually switch this out to a simple RNN here. If you want to do multiple long short-term memory networks, you have to do something like this. The first network layer has to return a sequence, and then that is fed into this next layer here. So if you want to set up multiple layers, do that. But initially, we're just going to have you do, let's go back to how it was, just one long short-term memory network with 32 nodes feeding into 16, feeding into 1. So that's our network. And now we're going to train it for 100 epochs. So it'll go through our data set 100 times. So that, again, there's 1951 training sequences. It'll go through those each, and then we'll do 100 times here. Now we're not tracking the loss here. We're just the accuracy. We're just tracking the loss here. And so this number should get smaller and smaller over time. So I'll just pause it while this finishes. Okay, training is done now. I probably didn't need to train that long. The loss kind of dropped down to about 4 to the -5th here, and it's been that way for quite a while here. But after like 75, it stayed about the same. But okay, that's trained. Now we're going to try to do some predictions. The first thing we're going to do is predict one step ahead. So if you know the last 48 months, can you predict what the next month's sunspot data is? And this should be relatively easy for the network to do here. And so what we have here is the original sunspot data is in dotted lines, and then the predictions are here. So we feed the network a set the last 48 months and then have it predict what the next month is. So that's what we're doing. We're using the training data and the test data and generating the predictions, and then we're plotting this stuff. We're also plotting the original sunspot data, and this little colon means it's a dotted line. So the dotted line here is the original sunspot data. So sometimes if this isn't performing well, you'll see the particularly at the peaks or the valleys, the predictions will be off a little bit, where it will start thinking it might overshoot, might think this is going to go up too much. And in fact, if you look at some of these, the green line, it predicts it keeps going up, up, up a little bit above the dotted line. It's hard to see that, but again, we're only predicting 1 month ahead here. But it's not bad. It follows it again quite closely. And then again, the green is the data it was trained on. If we provide it new data, the red data is the testing data hasn't seen. And again, it predicts pretty well for that. And so you can describe that now. The next thing we want to do is generate a sequence looking more ahead. Again, plotting 1 month ahead after seeing the last set of months isn't too bad. Again, if you see yourself going, sunspots going up, 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 your next prediction is probably going to be up. Same if you're seeing it going down, 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 your prediction is probably going to be down for the next month. But long term, it's a little harder. So here what we're doing is we're having it predict 360 months ahead here. So that's 30 years ahead. And so it should hopefully be able to kind of recognize there's a cycle to this and predict some sort of cycle. So again, the dotted line is an example of the sunspot data. And again, we should see it going up and down about every 11 years or so here. And then the question is that can our model, and this is our green line here, learn the same cycles? And it seems, it does some of that. So again, you can kind of look at this and try to determine how well it's learning that. So you're supposed to work on task 4 to answer a couple questions, and then task 5 is to do some modifications to this network. As we mentioned above, you can do modifications. You can change the number of units here. You can switch to a simple recurrent network, you can stack 2 layers on top. Just make sure the first layer of has to have this return sequence is true. Here you can try a different size dense layer here. You also feel free. We're training on sequences of 48. So 4 months worth of 4 years worth of data. You can make this longer or smaller if you want to train the data on longer sequences to see this. And then normal stuff you can also change epochs and stuff like that, whatever you want. So I want you to do 2 changes at least and record your descriptions of those here. Okay, good luck.